Shall we start, ma'am?
Yes, sir.
Shall we start, ma'am?
Yes. Start பண்ணலாம். Good evening, student. In 9th Science today, topic is Newton's law of motion. Newton's law is one of the interesting law because it is three laws. Newton's law is oriented in our day-to-day life activities. Okay, each and every law is useful to our life. So the first law of Newton's law in yes, every body continues to be in the state of rest or the state of uniform motion along straight line are acted upon that by same. So this is the concept of first law. First law, yes, Newton's first law is each and every body continues to be in the state of uniform motion along that straight line. So this is the basic concept because we want to need some energy to do that some work. I want to move a bench means I need some energy. I want to move means yes, I push the bench means the bench is move in front. Okay. Or otherwise I pull the door means the door is pull into that area. So each and every body contains to be in the state of rest or the state of uniform motion. Okay. So first, this what is the concept? Every body contains to be in its state or state of rest or the state of uniform motion. So this is the concept of Newton's first law. Each and every body contains to be in its state of rest or state of uniform motion along a straight line. So this concept gives the definition of force and inertia. The first law concept is related to the force and inertia. Okay, what is force? Force is the external effort to the form of push or pull. Okay, so force means force need. Force is we want to move that area, we want to walk in that place means we need some work. Okay, so pushing or pulling action. Okay, so force and an external effort in the form of push or pull. This is a concept of force. The first law of Newton's law is every body contains to be in its state of rest or the state of uniform motion. This is the first law of Newton's law. So it gives the definition of force and as well as the inertia concept also. So next up, suppose what is force? Force is an external effort. What is external effort? We want to do some work means we need that energy. With the help of external effort, we do some work. Force is nothing but external effort. External effort in the form of pull or push. In the form of pull or push. So this is the explanation of force. So it produces produce the motion of static body. Okay, so first one, it produces or tries to produce the motion of static body, and then stop or tries to stop moving body, or otherwise change or tries in the change of direction of motion moving the body. Okay, first one, produced to the motion of static body means, that is, I want to move the bench or chair means in that area. The first concept produces or tries to produce the motion of static body. Produce the motion of static body means it was in that state condition, rest condition. So the pen is in rest condition. I want to move the pen means I take the pen and keep it in another side. So this is the first concept. Produce the motion of static body. Stop or tries the moving body. Stop or tries the moving body. So we want to stop the watch, wall clock. Wall clock is always rotate. Okay. So we want to stop the watch means the stop of moving body, or otherwise now we are moving in two-wheeler or four-wheeler, we reach in that particular point means we automatically we off the vehicle. We switch off the vehicle, or otherwise the fan is rotate in our hall. We want to move that area means automatically we want just we switch off the fan. So that is acceptable for the second condition, that is stops or tries to stop the moving body. Third point, changes or change the direction of motion. Direction of motion means we are traveling in a two-wheeler or four-wheeler. Each and every, it is not a straight path. That turning also come in our area. So at that time, we want to move, or just we want to change the direction of the vehicle and that place. So the third concept is acceptable, that place. Change the direction of motion. Change the direction of motion. So that is the third point of that force. First, force is nothing but external effort in the form of push or pull. So there are three kinds. Okay, first thing is just move the bench is the first point. Move the bench is the best example for the first point. Second point, fan switch, or otherwise we want to off that car or two-wheeler or four-wheeler. And then third point is direction means car or our two-wheeler direction changes. So these 3 points are accepted for this example. So from our day-to-day life, force means the external effort to move the material, that is push or pull. Okay, what are the types of forces? Based on the direction which the forces act, they can be classified into two types. One is like parallel forces and another one is unlike parallel forces. One is like parallel force, types of forces. Like parallel. First one is like parallel force. What is like parallel force? Two or more forces are equal or unequal magnitude acting along the same direction, parallel to each other, are called as parallel forces. Like parallel forces is two or more forces. Two or more forces is acting at equal or unequal. Equal or unequal forces. Both forces are equal or unequal, acting along same direction. So this kind of forces is called as like parallel forces. Two or more forces equal or unequal magnitude acting along the same directions. So parallel to each other is called as like parallel. Unlike parallel, two or more equal or unequal forces along the opposite direction. The direction is changed in that place. Opposite direction to each other. This kind of forces is called as unlike parallel forces. And unlike parallel forces means two or more equal or unequal forces along the opposite direction or parallel to each other is called as unlike parallel forces. I think I show the simulation for the forces in last class. Yes, first one is parallel forces. Yes, first forces parallel forces acting on the same direction. Direction is same, one or two or more. So this is F1, this is F2. The F1 and F2 act on the same direction in this area. So this is the example of parallel forces acting on in same direction. In the same direction, these two forces are acting in this place. So the resultant forces, the resultant force F net force equal to F1 plus F2. Yes, these F1 and F2 forces, this addition of F1 plus F2, both forces are equal to that net force. So the F1, F2 is acting on the same direction. So the net forces equal to the same, F1 plus F2. Next one is parallel unequal forces. Parallel unequal forces. First case, both are in same forces. Just you consider the F1 is in age of 10 and then F2 force same age of 10 only. But unequal forces case, F1, F2. F1 is 25 years old man. F2 forces only 5 years small boy. So the forces differ in this area because depends upon the age. F1 is 25 years old man. So it has higher energy. Energy is more compared to the 5 years small boy. Okay. So the parallel unequal forces acting on the opposite direction or same direction. So opposite direction means in this area, F1 is 21, F2 is 5 years by. So, in opposite direction, so the forces acting unequal forces in opposite direction, the energy is high in this left side. The right side energy is very lesser because the force is very low. That person age is only 5 years. In this case, net force of F1 minus F2. So, F1 is greater than F2 is one case. And another case, F2 is lesser than one case. Okay. So, there are two kinds of forces will be act in this area. So, for example, here 5 years by, here 25 years young man. So in that case, F2 is lesser than F1. Okay, so there are two kinds of forces will be in that places. Next one, first one, parallel forces acting on same direction. Both are same age, both forces are equal in this place. Parallel unequal forces in opposite direction. So in this case, there are two kind of answer is possible. And then third one, parallel equal forces. Parallel equal forces. Both side persons age is 10 years only. So the force is equal in both direction. Yes, the parallel equal forces and acting in opposite direction. So in this case, there are third kind, that same line of action, that is F1 equal to F2. Both forces are equal. So there is no movement in this place. That is the third case. The net force equal to F1 minus F2 equal to 0. So this is the answer for the third case. So first one, both parallel forces on same direction. Second one, different kinds of forces in opposite direction. Third case, parallel equal forces in opposite direction. Okay. So in this first one, what is Newton's law? We learn Newton's law. Every body contains to be the state of rest or the state of uniform motion and a straight line. So this Newton first law is defined force and inertia. So what is force? Force is the external effect in the form of push or pull. What are the 3 points? That is 3 phases. One is produce the motion of static body, it is applicable, and second one, stop or tries to stop a moving body and then change the direction of moving body. So in this case, the force is applicable in that area. So there are two kinds of forces. One is like parallel forces, another one is unlike parallel forces. Like parallel means two or more forces equal or unequal magnitude on that same direction is called as parallel. Like parallel, unlike parallel means opposite, the direction only changed in that area. Okay, next one is Newton's second law of motion. Second one, Newton's second law. Yes, what is Newton's second law? The force acting on a body is directly proportional to the range of the rate of change of linear momentum of the body, and the change in momentum takes place in the direction of the force. Yes, one mandatory rule, we don't want to change the words in the law. Okay, yeah, you don't write your own words to frame a law. So the force acting on a body, the force acting on a body is directly proportional to the rate of change of linear momentum of the body. And the change in the momentum direction of the force. So, this is Newton's second law. The force acting on a body is directly proportional to the rate of change of linear momentum of the body. And the change in the momentum takes place in the direction of the force. This is the law, Newton's second law. So the law helps to measure the amount of the force. The Newton's second law is help to measure the amount of force. So it is otherwise called as law of force. Define law of force. This is the question, means you want to write the Newton's second law. Newton's second law is otherwise called as law of force because Newton's second law help to measure the amount of force only. So in this case, for example, you want to move a body, means the body mass is called as m, letter m, and moving along a straight line means the initial speed is calculated in letter u, and the interval of time duration is denoted as t, and then velocity of the body changes, that is speed, is calculated as, is denoted as phi. So the impact of an unbalanced external force is denoted as F. So this let M is the mass of moving body along straight line in the speed is calculated as U, and then time interval is t, and velocity of the body is v. Impact and unbalanced external forces, yes, denoted F. So the initial momentum of the body is mu. The mass of the body is m. Initial speed is u. So pi equal to mu. Initial momentum of the body. This is the derivation of Newton's second law. Initial momentum. Initial momentum of the body is equal to Pi is equal to mu. And next, the final momentum of the body. Final momentum of the body is Pi equal to mv. Initial speed is denoted the letter u, and then final speed is denoted letter v. So change in momentum. Initial momentum is mu, final momentum is mu. So change in momentum. Change in momentum is equal to delta P. So this triangle is tell us delta. Delta P equal to, so final momentum minus initial momentum. So that is the normal formula, is it? The final, we want to calculate the changing in momentum means we want to write that, we want to subtract the final momentum to initial momentum. So here minus Pi. So the final momentum is mv, that is PR minus mv. So as per Newton's law, delta P, PR minus PV is equal to mv minus mu. mv minus mu. So as per the Newton's second law, yes, which one is the proportional? Yes, the rate force is proportional to the rate of change of momentum. F is proportional to the rate of change of momentum. Rate of change of momentum as per the Newton's second law. That is the concept of Newton's second law. So, F is proportional to rate of change of momentum. That is rate of change of momentum by time. F is proportional rate of change of momentum by time. So F is proportional mv minus mu by t. This is the final momentum. This is initial momentum divided by time. So here F is a constant. So K is constant Km V minus. So M is common for both. So M into V minus U by T. So K is the constant here, proportionally constant. So K is considered 1. So K is the value of 1. Constant means the value of constant is only 1. So F equal to Km V minus U by T. So M V minus U by T. So this is the right formula of the Newton's second law. F equal to mv minus u by t. So acceleration is equal to change of velocity. That is A. A equal to v minus u. A is equal to v minus u. That is acceleration equal to change in velocity. So we want to change the formula here. F equal to m into A. This is the right formula of Newton's second law. F is equal to m into A. Force. F is force. Force equal to mass into acceleration. Force, we want to calculate the force, means we need mass and the acceleration value. Mass into acceleration. Force equal to mass into acceleration is the formula of the Newton's second law. So, no, the external force is required to maintain the motion. Each and every motion, we need some external forces to apply the body in the uniform velocity. So the net forces acting on the body is not equal to 0. Definitely the velocity of the body will change. So the force required to produce the acceleration of the body. So the uniform circular motion is in that speed remain constant. So the direction of the velocity is at every point in that path only. Okay. So now I'm going to explain the concept with the help of one simulation. Yes, in this simulation, we are going to learn the Newton's second law. Second law concept. Yes, what are the materials are available? Yes, this is the weight. Okay, ma. Yes, I accept. Yes, what are the components are here? So mass of the cart. Okay, some masses we want to increase the masses in this place. Some weight are hanging in this place with the help of this two materials as well as the time machine also here. Yes, we want to calculate the right time period in this action. First one, mass of the select the environment. There are different kinds of environments are here. Earth, Uranus, Jupiter, and Moon. There are 4 kinds of environment. One is Earth, Uranus, Jupiter, Moon are the space planets. So in these 4 environment, we are going to do the simulation. First one, I am choosing the Earth environment. Yes, I am taking 100 grams. Yes, 150 grams. Show here 3 stones are equal to 150 gram. Vertical mass. Yes, vertical mass is here. I am choosing 150. That is same. 3 stones are here. Each and every weight has 50 gram. Distance travel. Yes, I want to change the rod here. This is denote the distance between these 2 places. Not going,
மேம்
sir.
அனடைப் பண்ற ஆப்ஷன் ஆஃப் பண்ணிருங்க மேம். நீங்க ஸ்டூடெண்ட்ஸ் இது பண்ணிக்கிட்டே இருக்காங்க.
Yes, 1 second. அப்ளை ஆகலையே.
ஹலோ
சார் அப்ளை ஆக மாட்டேங்குது, இருங்க. எஸ். Okay. Now I am start the simulation. I am taking 250 gram in this cart and 150 gram in vertical masses, and distance I am choosing 200 meters, 250 centimeter. Now I am start the simulation. Yes, what is done here? Please recall the second law of Newton's second law, that is force acting on a body is directly proportional to the rate of change of linear momentum. Yes, the cart is moving here. That is certain area. The same distance is equal the vertical mass, that is the weight also decreased in this area. Okay, so this is the first case is applicable for Newton's second law. The force acting on a body is directly proportional to the change of linear momentum, and change in momentum in that same direction force. The same direction forces is equal. That is directly proportional. Okay, now I am changing the mass of cart. Yes, mass of cart is 400 gram. Yes, just you count the balls. 1, 2, 3, 4, 5, 6, 7, 8. So 8 5s are 40. 400 gram the mass of cart, and then vertical mass is also 350. This is also same 400. 8 weights are hanging here. The distance also higher. So look at the distance. Look at the distance between the cart and the wooden scale. So now I'm starting the simulation. Yes, what is done? Yes, the cart is moving in front. The weight is higher in the cart, as well as the weight of the vertical mass also higher. So both distance are same, directly proportional. Okay. So in this case also, we can conclude the second law is applicable. Look at the timing also. Sorry, 1.280 seconds is taking to the cart is moving in this place. The graphical structure also same. The minutes, direction, and then time, both are same movement. So now I am, yes, I am selecting only 100 gram. Vertical mass is 350 gram. So distance is also higher. So the mass of the cart is lesser. The vertical mass is higher. The distance also higher. What is going here? Yes, the cart is move fast within 0.958 second, millisecond. The cart is move fast because it is lesser weight. The cart weight is only 100 gram, and then vertical mass weight is 350 grams. So it pull fast in the heart. So in this case also, we understand the second law of the application. Now I am change the environment in moon. Look at the second, the time duration is differ from one environment to another environment. Okay, so what is the difference? Because the gravitational force also differ each and every place. The gravitational forces differ. So in this area, moon, the cart having only 150 gram weight, vertical mass also 150 gram. The distance is higher. Okay, distance is little bit high. Now I am, sorry. Yes, I'm starting this. Yes, look at the speed of the movement. Yes, it takes 2.740, 2 second, 0.740 millisecond cart to move in this area. The graphical structure also in slope line because the time duration is higher to taking travel in this place because the gravitational forces differ from earth to moon. Okay, so the gravitational force is high in our earth compared to moon. So the carters move very slow. So now I'm changing the weight of the cart. The same moon environment. Environment is same. The weight of the cart, the mass of the cart is 300 gram, and then vertical mass also 300 gram. Distance are nearly 200 centimeter. So look at that changes. Yes, this very fast because both are same weight. The mass cart weight is 300 gram. Then vertical mass weight is also 300. Yes, look at the time duration is 1.200. 1 second and then 200 millisecond takes the cart moves in this area. So now I am changing the environment in Uranus planet. Okay, definitely the force, gravitational forces differ from Earth to Uranus. Yes, the mass of the cart is 200 gram and then vertical mass is 250. There are 5 weight stones are hanging here and then distance travel is 250 centimeter. So look at the time duration. Yes, 1.130 millisecond. The cart is moving in this place. The graphical structure also nearly in straight line. Okay, so because of the gravitational force difference, the cart is move. So the same concept, second law is applicable in that area also. Acting on a body, forces directly proportional change of Linear momentum and the change in momentum takes place in the force of the direction, force of the same direction, place in the direction of force. This force means the weight is pull that machine. So next one, choosing Jupiter. Yes, in Jupiter planet, we are going to do the same simulation. I am choosing, yes, higher place, 450 gram, vertical mass also 500, and distance also higher, that is 450 centimeter. Yes, look at the time duration is 1.320 millisecond, 320 millisecond. The cart is moving in Jupiter environment. In Jupiter environment, the weight is I think compared to the moon and then earth, it is very fast because we what are the environment we do that? Earth, moon and Uranus. So compared to the three, I think Jupiter, earth is normal, and then second place I think Jupiter. Okay, is that right or wrong? Have you all observed the time duration? Did you write the time duration in your notebook? That is the result of the simulation. Okay. So what is the time duration taken in this area? That is the result of the simulation. So we done in the four environment. First one, earth, and second I am choose that moon. Third one is Uranus. Fourth, Jupiter. In Jupiter environment, we are selecting the mass of cart is 450, vertical mass is 500, more or less equal, a little bit higher compared to the mass of cart, and then distance is equal to 450 centimeter. So in this area, the time is 1 second 320 milliseconds. So the graphical structure also, it got light slope only. Okay, so with this simulation we can understand the second law, Newton's second law. Students, did you all understand this simulation? Is there any doubt? Please ask me clearly. Don't write it. Just raise your hand, or otherwise just you type the details in clear manner. Okay. Definitely I will reply. I will explain your questions also. Don't scribble because it will disturb to another places. This is my humble request. Okay. So first one, you should, yes, mandatory. Please you ask the doubts and the clarifications in the right proper manner. That is my request. Okay, you please raise your hand, or otherwise you type clearly. Definitely I will explain the answer, or is there any clarification, or definitely I will explain the concept in that second time also. Okay, is that clear, students? The simulation details is clear? Did you understand the concept of Newton's second law? I think a very clear idea we will get with the help of the simulation, Newton's second law concept. Yes, in this session we learned first one, what is for Newton's first law. Newton's first law is applicable in force. So we learned the concept of force and the types of forces like parallel and unlike parallel forces, and then we study the second law of motion, that is Newton second law of motion. So next, units of force, the SI unit of force. What is the unit of force means? Yes, that units of force. What is the unit of forces? The SI unit of forces Newton. The SI unit of forces considered as Newton. In CGS system, it is called as dyne. First one is SI unit. Second one, dyne means CGS system. It is considered as dyne. So, what is the unit of force means? That is Newton, N. And define what is dyne. Dyne means the amount of force required for a body of mass 1 gram produces the acceleration. That is, 1 dyne is equal to 1 gram centimeter second per minus 2. This is the explanation of 1 dyne. That is 1 N equal to 10 power 5 dyne. 1 Newton equal to 10 power 5 dyne. This is the value of dyne. Okay. Dyne means amount of force required the body 1 gram produce the acceleration 1 centimeter second per minus 2. So 1 dyne equal to 1 gram centimeter second per minus 2. 1 N equal to 10 power 5 dyne. Okay. So next one is what is Newton? That is N. What is Newton? Newton is the amount of force required the body of mass 1 kilogram produce the acceleration. That is 1 meter second per minus 2. 1 meter second per minus 2. That is 1 N. The value of 1 N equal to 1 kilogram meter second per minus 2. This is the value of Newton. 1 N equal to 1 kilogram m meter second per minus 2. The amount of force required for your body is 1 kilogram. Produce an acceleration of 1 meter second per minus 2. So that is the value of 1. So unit of force means SI unit is Newton. N. In CGS system, we termed as dyne. So definition of Newton, that is amount of force required 1 and equal to 1 kilogram meter per meter second per minus 2. 1 dyne equal to 1 gram centimeter second per minus 2. This is the value of 1 dyne. So that is 1 N equal to 10 power minus dyne. Next one is unit of force. What is the unit of force means? The amount of force required produce the acceleration of the body is 1 kilogram. The amount of force required to produce an acceleration of 1 meter second per minus 2 in a body of mass of 1 kilogram is called unit force. So what is unit force means? The amount of force required to produce an acceleration of 1 meter second per minus 2 in a body of mass of 1 kilogram is called as unit force. What is the gravitational unit? Yes, the gravitational force, the gravitational unit of force is gravitational unit of force, kilogram force, represented as kgf. In SI. In CGS system, that is represented by GF, that is gravitational force. 1 kgf equal to 1 kilogram into 9.8 meter second minus 2. Yes, each and every sum we will apply the value of this. Okay, gravitational unit of force is 1 kgf is equal to 1 kg into 9.8 meter second per minus 2. That is 9.8 Newton. So 1 GF is equal to 1 G into 980 centimeter squared. This is kgf or 1 GF, that is in CGS system. 1 G into 980 centimeter per minus 2, that is 980 dyne. Okay, this is the value of 1 GF. Value of 1 GF is 980 dyne. So, this is gravitational unit of force. What is unit of force means? This explanation is enough. This is gravitational unit of force. Gravitational unit of force, though 1 GF is equal to 1 G into 980. 1 kgf is equal to 1 kg into 9.8 meter second minus 2. Okay. So, the third one is Newton's third law. Is there any doubt in first two laws? Newton's first law and second law? Okay. Shall we move to the third law? That is Newton's third law. Very simple concept. Every action, there is an equal and opposite reaction. This is the concept of third law. Third law concept is very simple. Each and every action, there is an equal and opposite reaction. Always act on two different bodies. For every action, there is an equal and opposite reaction. This is the concept of Newton's third law. They always act on two different bodies. This is the concept of third law, very important law. Each and every actions we feel. What are the examples? If a body A applies the force Fa on a body to B, the body B reacts with the force of Fb on the body. So, which are equal? Though Fa which is equal to the Fa in magnitude opposite direction. Okay. So, this concept is applicable for the birds flying concept. When the birds are fly, they push the air downwards with their wings. That is the action. And the air pushes the bird upwards. Same concept is a rocket propulsion. Rocket propulsion concept also applicable. The third law is applicable in the rocket. Each and every rocket propulsion and then the birds flying concept. Okay. For every action, there is an equal opposite reaction. Example of our day-to-day life for the third law. The birds flying. Yes, the bird is flying. Push the air towards. Push the air, downwards. And then same time with their wings. This is the action. Another one is reaction. The air is pushes the bird upwards. Yes. The opposite of downward is upward. So, this is the reaction. Each and every action as an equal opposite reaction. So the bird fly push the air downwards with the help of their wings. The air pushes the bird upwards. That is the reaction. So this is the best example for the Newton's third law. And then same next one is swimming concept. Yes, swimming game is very interesting, is it or not? Yes, the person swim, he push the water. He push the water is the action. Okay, using their hands in backward reaction. That is the action. First one is action. A person swims, he push the water in backwards. Next one, the water also pushes the swimmer in the forward portion. Okay, forward direction. This is the reaction of the action. Person swims, push the water in backwards. Just you imagine the swimmer push the water in backward position. That is the action. The water also push the swimmer in the forward direction. That is the reaction of the action. So this is also the best example of third law of Newton's. And third one, bullet. Okay, very good example. Yes, you fired the bullet. The gun recoils backward. Just you imagine the gun. So, the gun is recoiled backward and the bullet is moving forward. Bullet is moving forward direction. So, this is the action. And then opposite, the gun equalize the forward action. The gun equalizes the forward action. This is the reaction of the action. Forward action. So the gun is equalize the forward action by moving backward. So this is the reaction. The first one, action, means you fire a bullet, the gun recoils backward, the bullet is moving forward. That is the action. The gun equalizes the forward by moving the backward reaction. That is backward action. So backward direction. So this is the reaction of this action. So these are all the very good example of third law. What is third law? Every action, there is an equal opposite reaction. So they always act on two different bodies. Yes, two different bodies means the bird fly push the air downwards as well as the air pushes the bird in upwards. So two different bodies means one is bird, another one is air. And then second one is swimmer and then water. So different kinds of bodies, gun and bullet. So there are two different kinds of bodies. The law is applicable in that condition. Do you have any idea? Is there any other, some more example for this? Students? Yes, you are also always brilliant, charming person, sit or not, young charm. Is there any some more example for the third law? Yes, this is your task. Do you have any idea about the examples of the third law? Yes, today's date is 7/1/2005 in ninth standard science session. Task is examples for Newton's third law. Yes, please write down some more examples for Newton's third law. Yes, I explained three very good example, that is birds flying action, and then swimming action, and then bullet and gun action. You please write down one or two examples for Newton's third law. This is your task of ninth standard science in this date. Okay. Is there any doubt, ma? So just you go revise all the chapters, three laws of Newton's law concepts and the derivation also. Just you recall the simulation concept. I explained the simulation for Newton's second law. So I think it was very useful to you. Read the portion. Is there any doubt? You please ask in next class. Okay. Thank you, students. Jai Hind, Jai Vidya Shakti, Jai Bharat.